Boom, exponential function. You guys see it? That's the exponential function. In fact, it doesn't matter what is there. I have a 2 there, but I can put an a there, make a slider, and then say from 1 to 10 will be my range there. Okay, and if I plug in whatever number I want into a, the exponential function still kind of behaves the same, except when it's 1. Now you can't be 1 there. Okay, so these are all exponential functions as the base changes right here. Let's stop it right there. That looks good. Let's make this into a 4. So if I have a base 4, this is what it looks like. When you change the base, it changes the curvature of the line. It starts curving more sharply the bigger the base is. Now there's a rule with exponential functions, and that rule is this. Your a cannot be negative. Can you put a negative outside of it? Absolutely. And if you do that, it changes all the y values from being positive to negative. Everybody sees that? Yes, yes, yes. What happens if you put a negative in front of the x? That will change all the x values. All the x values on this side will then be the x values on this side. And so the function would reflect over what?
The y-axis.
It will reflect over the y-axis, and there it goes. Okay? All right. So I want to talk about 2 more things, and that's a couple of different shifts that can happen with the exponential function. But first, we need to identify our asymptote for this exponential function. Is the asymptote going to be y equals or x equals? The answer is y. It's y equals. Y equals what?
0.
0. Okay, so y equals 0 is going to be our horizontal asymptote. Let's make it a dotted line. There you go. There's my horizontal asymptote. Now, let's shift this function, this exponential function. If I shift this exponential function up, that's what it looks like. And so, I mean, you guys, we've worked with HK a lot, you know. 2 would be your K. Now, is the asymptote still a 0? No, it's not. What is my asymptote now? My asymptote is 2. Okay, because the whole function shifted up 2. Check this out. Let's add a K to it. Let's make a slider. Let's make this, just go from negative 5 to 5 because that's in our window. All right, so if I go like this, you guys can see the function just shifting all over the place. You see that? See that? Okay, but what is not moving with it that should be moving with it? The horizontal asymptote. So what am I going to make my horizontal asymptote equal to? I'm going to make it equal to K. And now he's going to follow him. Okay, so that is shifting exponential function up and down. Let's, just for fun, shift it up and down and change the base. Oh, look at that.
It's beautiful.
Yeah, isn't that great?
Like breaks its back on the thing.
Well, bam! It's almost like the exponential function is whipping the asymptote. So, what would a horizontal shift look like? Well, it would have to be stuff happening inside the exponent. So, like, if I were to subtract 2, what do you guys think is going to happen? Where is it going to shift our function if I subtract 2? Subtract 2! Where did it shift? Shifted to the right. It shifted to the right. So this is your h. We've been working with h a lot. Let's add a slider for that. So if we were to change our h, it shifts to the left and to the right. It almost looks like it's laying down on the asymptote. But if we were to zoom out, you can clearly see it is shifting to the left and to the right. It's just moving left and right. Okay, go back to our home here. And I think that's it. I think that's all I want to tell you guys. I forgot to tell you guys one more thing. You guys see this point right here? It's a very important point. On exponential functions, that point is always there. Actually, you know what? I don't think I defined the function. Whoops. That guy's got to go away. All right, I got to define this as f of x. So I go f of x. There you go. What is that point?
0, 1.
Now watch what happens when I change the base. I'm changing the base. The a is changing. Does that point ever change? No, that point's always going to be right there. It doesn't matter what base it is always going to have the point 0, 1. Why? Why is that? Tell your neighbor if you know. So because anything raised to the 0 power is 1, that's why this point always exists. All right, now let's talk about the inverse function of the exponential function.